A very good morning, friends. Today we will discuss about an important topic, that is lipoprotein. As we take fat in the diet that get absorbed through the gastrointestinal tract, and there is synthesis of lipid in the liver and adipose tissue. These lipids are insoluble in water. These lipids must be transported to the various tissue for their utilization and storage. So transport is required for their utilization and storage. As these are not soluble in water or insoluble in water, they get complexed with the protein to form a structure that is known as lipoprotein. So lipoprotein is a lipid plus protein. This protein part of lipoprotein, it is known as apoprotein or apolipoproteins. And this lipid, it is mainly of two types. The first one is the non-polar lipid, and second one is the amphipathic lipids. Now coming to the structure of lipoprotein. In the lipoprotein structure, it is made up of inner core to this inner core there is outer monolayer, a single layer of amphipathic lipids. Amphipathic lipids mainly it includes phospholipid and cholesterol. So there is cholesterol in this layer. So suppose this is a cholesterol and this is a phospholipid with polar head on the outer side and non-polar tail in the inner sides. So this is cholesterol and this is phospholipid. Inner core of this lipoprotein, it is mainly composed of Tg, this is Tg, and cholesterol ester. This is cholesterol, this is ester. This is triacylglycerol. So this is the inner core of lipoprotein, which is made up of non-polar lipids, that is triacylglycerol and cholesterol esters. Then outer monolayer, it is made up of amphipathic lipids with polar end towards the outer side, that is in the aqueous medium, and non-polar ends toward the core of the lipoprotein. Then it is again having a peripheral proteins and integral proteins. So this is integral protein, this is peripheral protein. So this is the structure of lipoprotein. It is made up of lipids, that is non-polar, amphipathic, and protein, that is integral and peripheral. And this protein part of lipoprotein is known as apoprotein. It is of apo A, which includes apo A1, A2 and A4. Then apo B, that is 48, and 100. Then ApoC, that is 1, 2 and 3. Then ApoD and ApoE. These are the major apoproteins which are present in the lipoprotein. Now coming to the classification of lipoproteins. In the classification, these lipoproteins are classified on the basis of their density and second, their electrophoretic mobility. So classification on the basis of density, that is by ultracentrifugation. This is a test tube. In the ultracentrifugation, the lipoprotein with the highest density settle down at the bottom. So it contains the free fatty acid complexed with the albumin. Then second, it is HDL. Then LDL. IDL, that is intermediate density lipoprotein. This is VLDL and chylomicrons. So depending on their density, they get separated and they are classified as chylomicron, VLDL, intermediate density lipoprotein, low density lipoprotein, high density lipoproteins. So if you see the density, the chylomicron having the density, it is less than 0.95 gram per liter. Then VLDL, it is 0.95 to 1.006. IDL, it is 1.006 to 1.019. Then LDL, the density is 1.019 to 1.063. HDL, it is 1.063 to 1.125, and free fatty acid complex with the albumin, it is more than 1.215. So this is the density. The highest density is at the bottom, and the lowest one, that is chylomicron with the highest lipid content, it is at the top of the test tube in ultracentrifugation. Second classification, it is based on the electrophoretic mobility, which is mainly dependent on the size and the protein content. So in electrophoretic mobility, this is positive, this is negative, this is origin. So chylomicron, it is at the origin. Then HDL, this is the free fatty acid complex with the albumin, followed by the HDL. It is also known as alpha lipoprotein. Then pre-beta, broad beta and the beta. This is pre-beta, that is VLDL. This is broad beta, that is IDL, and this is low density lipoprotein, that is beta lipoprotein. So this is how lipoproteins are classified on the basis of their density and their electrophoretic mobility. So it is electrophoretic mobility. Now coming to the some characteristic of these lipoproteins. The first important point in the characteristic is the density. All of you know that HDL is highly dense and chylomicron is the least dense lipoprotein. Second one is the protein content. This is chylomicron, then VLDL, IDL, LDL, HDL. So it is the highly dense lipoprotein. This one is the least dense. Then protein content. The chylomicron contain near about 1% of the protein. VLDL it is 7 to 10%, IDL 11%, LDL 21%, and HDL it contains 30 to 60% of protein, depending upon the type of HDL, whether it is HDL 1, 2, 3 or it is pre-HDL. Then lipid content. The chylomicron contain 99% of lipid. This is 90 to 93% of lipid. Ideal 89% of lipid. Then LDL it is 79% of lipid, and HDL content of lipid it varies. HDL contain mainly 40% to 70% of lipid. So the major lipid in chylomicron it is triacyl glycerol, phospholipid and cholesterol. In VLDL it is triacyl glycerol. In IDL it is cholesterol. LDL it is cholesterol, and HDL it is phospholipid and cholesterol. Then major apoproteins. Apoproteins. In chylomicron it is ApoB48. This one is the major. It is a example of RNA editing. The synthesis of ApoB48 it occurs in the intestine, and due to the premature termination there is only 40% of ApoB is synthesized. That's why it is known as ApoB48. Then VLDL it contains B100. It also contains C1, C2 and C3. This chylomicron along with this V48 it also contains ApoA. Then it contains ApoC, ApoE. This VLDL it is B100 is the main, and ApoC2 this is the mainly the ApoC2. Then IDL it contains B100 and ApoE. This is the LDL, that is the bad cholesterol, it contains only B100, and this contains ApoA. This is the ApoA, that is 1, 2 and 4. Then it does not contain ApoB, it contains ApoC, that is 1, 2, 3. Then ApoD and ApoE. The one MCQ is here. This ApoD it is thought to be responsible for neurodegenerative disorders. It is responsible for neurodegenerative disorders. Now coming to the important functions of lipoproteins. This chylomicron, the important role of chylomicron is to transport the triacyl glycerol, that is the exogenous TG, means dietary triacyl glycerol, from gastrointestinal tract to the peripheral tissue, means muscle and adipose tissue. Muscle and adipose tissue. So this is a MCQ, that is chylomicron is responsible for transport of exogenous triacyl glycerol. Then VLDL, it is important in the transport of endogenous TG, that means endogenous triacyl glycerol. That means it is responsible for transport of TG from liver to the peripheral tissue, that is muscle and adipose tissue. Then LDL, it is responsible for transport of cholesterol from liver to the peripheral tissue. Hence it is known as bad cholesterol, because it get deposited, cholesterol get deposited in the peripheral tissue, that leads to the atherosclerosis. That's why it is regarded as the bad cholesterol. And this HDL, it is known as good cholesterol. It is responsible for reverse transport of cholesterol. HDL, it is responsible for reverse transport of cholesterol, that is from peripheral tissue to the liver and their metabolism and elimination. So that it is known as good cholesterol. The enzyme which is responsible for reverse cholesterol transport is lecithin cholesterol acyl transferase, LCAT. It is important in the reverse transport of cholesterol. So these are the important functions of this lipoprotein. The apoprotein has important functions in the lipoprotein. They form the core, or they form the structure of lipoprotein. Second, they are responsible for activation of certain enzymes. For example, AC1 and 2, ApoA and ApoC. This ApoA1, it activates lecithin cholesterol acyl transferase. It activates LCAT. This is the important MCQ. And ApoC2, it activates lipoprotein lipase. Lipoprotein lipase. Then another important function of apolipoprotein is inhibition of certain enzymes. For example, AC23, these are responsible for inhibition of lipoprotein lipase. Again, they have a function as a they work as a ligand for the receptor of lipoproteins. So these are the important functions of lipoprotein. So summarizing the all, lipoproteins are complex of lipid and protein. They are made up of lipid and protein, as lipid is insoluble in water, and for the transport of lipid these lipoproteins are important. They are classified based on the ultracentrifugation and electrophoretic mobility. HDL is the lipoprotein with highest density, while chylomicron is the least dense lipoprotein. HDL contain more protein as compared to the others. HDL is responsible for reverse transport of cholesterol and cholesterol elimination and metabolism and elimination. That's why it is known as good cholesterol. The lecithin cholesterol acyl transferase is required for reverse transport of cholesterol. Then LDL is responsible for the moving of the cholesterol from liver to the peripheral tissue and responsible for deposition and atherosclerosis. The B100 is the major apoprotein in the LDL, while ApoA is the major apoprotein in the HDL. B48 and the B100, this is an example of RNA editing. They are synthesized from the same mRNA. It is synthesized in the intestine, it is in the liver. It is due to the premature termination of protein synthesis. Only 48% of B100 is synthesized in the intestine. Due to the premature termination is due to the stop codon after the 48% of its synthesis. Then Another one lipoprotein is a lipoprotein small a. It is written as lipoprotein small a. Atherogenic. It is also known as little rascal, and it is atherogenic. It has homology with the plasminogen. It has homology with plasminogen. It interferes with the fibrinolysis. Hence, it is responsible for the clot formation and atherosclerosis. That's why it is a bad lipoprotein, lipoprotein small a. It is also known as little rascal. So this is all about the chemistry of lipoprotein, different characteristics of lipoprotein, structure of lipoprotein, their classification and their important functions. So this is all about lipoprotein. Thank you. Keep watching.